I'm Shane Crandall. I wrote Promise. I'm a freelance software developer.
Welcome to Promise. Promise is a user-configured MTConnect client deployed as an intranet web application. It is a blank canvas to create custom views of real-time data from MTConnect devices. It allows any user to express, visualize, and share any MTConnect data in any context at any time. It doesn't target just one specific industry, equipment, or process. It targets them all. It was specifically designed to be an open solution to maximize its impact and usefulness. As a website, Promise requires a web server to host it, a modern web browser to use it, and a database to store user data. The only specialized skills necessary to install Promise are the deployment of an intranet web application and its associated database. No knowledge of MTConnect is required by an IT department since the end users configure their own data and visualizations. As such, Promise was designed to be intuitive, fast, and simple for those end users. The breakthrough concept of Promise is that it requires no system integrator. Rather, that power is transferred to the users. When the environment, processes, and users change, Promise can evolve and scale with them to continue being a benefit to manufacturing intelligence. Promise was designed to impose no constraints on its users. It and all of its dependencies are free. To see how Promise works, let's create a view to monitor some live MTConnect data. First, we'll create a new folder. A folder is a collection of more folders and widgets. Its purpose is to organize folders into a hierarchy into view widgets. Next, we'll create a new widget. A widget is a collection of tags and schedules. It is composed of behaviors that visually represent the changing state of those tags and schedules. Next, we'll create a new tag. A tag is an abstract representation of a single data source. A tag could represent a data item or a data element, depending on context. We'll enter the MTConnect agent address and probe it to find a tag. We'll expand the nodes to find the X-actual tag. To add the tag, we can drag it over into the widget. You can click on the tag to see its current value updating. Now we'll click on the folder to see our widget. The widget's value is 50 with a font color of white, a gray background, and a black border. We'll edit the widget to use the tag. The behavior named value gives the widget its value in default appearance. We want to use the tag as the value instead of 50, so hover over it to get its ID. Or just start typing the tag name, and autocomplete will suggest a tag. We'll go ahead and add a conditional behavior to change the widget's appearance if the value is greater than 0. Expressions can be composed of multiple tags from the same agent or different agents, as well as schedules. In addition, expressions can include any valid JavaScript operators and functions. Some of the most common functions are included in the expression wizard for convenience. Styles can include any valid CSS. Some of the most common styles are included in the Style Wizard for convenience. With this style setting, the widget background color will change to green if the value of the tag is greater than 0. Now we can click the folder to see the widget using the tag. If the tag value is less than 0, the background color is gray. If it's greater than 0, the background color is green. From here, we can also drag and resize the widget. Folders, widgets, and the site logo can all have custom background images. For example, we'll upload a new site logo to replace the Promise thumbs up logo in the bottom left corner. You can see the site logo has changed to these two gentlemen shaking hands. The hierarchy view was created to demonstrate the dual purpose of folders, which is hierarchical organization and displaying widgets. There is no limit to the nesting level of folders or to the number of their children. In this example, business units contain assembly lines which are made up of stations. Business Unit A is green because all of its assembly lines and stations are green. However, Business Unit B is yellow because both of its assembly lines are not green. Assembly line A is yellow because one of its stations is yellow, and assembly line B is red because one of its stations is red. To summarize, folders hold more folders to organize data and hold widgets to visualize data. The widgets view was created to demonstrate the 5 different types of widgets available. All widgets are using live MTConnect data from a local simulation agent. From left to right, the widgets are box, bar, gauge, chart, and queue. There are 2 queues, one with event data and one with condition data. A box is a one-dimensional widget for displaying any data type. A bar is a one-dimensional widget for displaying numeric data, normally as a percentage in a horizontal orientation. They are also useful for displaying fluid levels in a vertical orientation. A gauge is another one-dimensional widget for displaying numeric data. A chart is a two-dimensional line chart displaying a time series of numeric data. A queue is a two-dimensional widget for displaying a time series of any data type. It is intended to be the discrete counterpart to a chart for displaying events. In addition, it is a means to display multiple active conditions at one time as seen in the condition queue on the far right. In addition to tags, Promise also has pseudo tags called schedules. A schedule is an abstract representation of a daily schedule with an ordered collection of shifts. Among other things, schedules are necessary for an expression to calculate overall equipment effectiveness, OEE. This is the default schedule. It contains 3 shifts, and each shift contains 2 operation intervals, one before and after a half-hour break. Shifts and intervals can be added, removed, and rearranged as needed. From the schedule, the 2 bar widgets and chart widget at the top are able to calculate OEE, shift completion percentage, and the production target, respectively. This view is an example of an assembly line in a manufacturing environment. The background image is the actual layout. Each box widget represents a station with a station number followed by an OK and not OK part count. The box widget colors are based off the controller mode event of that station's PLC. All the data for the 26 stations is from a local MTConnect simulation agent written for this view. Notice the first station is S101 and the last station is S308. The last station's OK count is significantly lower than the first station's due to fallout from not OK parts. This is reflected in the OEE. Now we'll take a look at 2 additional views developed in Promise to show its capabilities. This is a machining view monitoring live data from agent.mtconnect.org. It applies the data to the naked view of a Kent KVR 2418 and its panel. 4 box widgets on the machine show access loads oriented with the axes. 5 box widgets on the panel LCD show the X, Y, and Z actual positions along the feed rate and spindle speeds. 4 more box widgets show the status of the power lamps, e-stop state, cycle start /feed hold lamps, and coolant alarm LED. Lastly, two gauge widgets on the panel show the feed rate and spindle override percentages. This is a boiler room view, monitoring truly random data not associated with any agent. It shows 5 pressure gauges and 2 temperature gauges along with 2 box widgets representing a flow meter. These box widgets demonstrate a widget's capability to have multiple background images switching dynamically, in this case 10 background images each mapped to an integer. That's Promise in a nutshell. We appreciate your time and consideration.